Hello, everyone. Thank you for coming today to this session. Today we will talk about metrics, observability, monitoring, Prometheus, and OpenShift. Before introducing ourselves, we've got some questions. So how many of you are currently monitoring their workloads? Well, almost everyone. That's good. So are you using an open source solution or a third party?
Open source, raise your hands.
Yeah.
Third party?
Well, that's good. So my name is Manuel Hernandez. I work as an integrations engineer at Sysdig.
And I'm Emanuela Zaccone. I'm the product manager for our Proncad integration, as we call them. So all about Prometheus integration. Plus, we also run an open source project called Proncad.io, which is a catalog of Prometheus integration. As you can imagine, it's all about Prometheus here.
Yeah.
So we will talk about it definitely today. So just to set the expectation, we are going to talk about what's the value out there of monitoring, so why we all should care. You said most of you actually are monitoring already your workloads, so we will deep dive into that. We will also go and start understanding what we mean when we talk about maturity path and what does that mean, especially in this context, and what we mean when we say turning data that we get from OpenShift into actionable insights. So, first things first, why we should be interested in monitoring. I know it might sound obvious, but if you try ask this same question to different customers or even to different people or different teams, especially different teams, you will get different answers. But the truth is, if we want to make sort of kind of a comprehensive list, there are things that are always recurring, things that you will always hear from all the teams and all the customers and people. We all want to early detect issues. That's the first thing, and actually the most important there, because otherwise it means losing a lot of time, wasting a lot of money, so it's kind of the most blocking thing out there. Of course, we want to optimize our performances, the performance of our environment, how we manage monitoring, how we manage observability and everything. Security and compliance is absolutely key. I mean, it's kind of obvious. We know how relevant it is, especially in cloud-native environments. And of course, we want to be able also to take informed decisions. So use this data not just to react to something that is happening on our environments, but rather to be able to prevent them, to think in advance to what we need to do and to do the right thing, because we got enough data to understand if what you're doing is what we need to. And why not? Enhance productivity. Because we got tons of people in the company that are all behind a fire because they need to respond to what is happening, and we didn't notice before because we were not monitoring. We're wasting a lot of resources. So that's definitely something that will affect the way today we approach this topic. And speaking of approaches, the truth is that Cloud Native changed everything. It's not just because everybody loves saying so. We all know that. We know what changed from an infrastructure standpoint. We know what changed in our everyday lives and how we approach our work. But we also know what that means. It means that we got, in most of the cases, multiple environments that are constantly changing, that use microservices, architecture, and containers. And all of these things need to be monitored and to do that on time. And how do we monitor them? When first this environment and architecture emerged, so Kubernetes was the first one, there was also this project that, no wonder, was the second graduated one from CNCF after Kubernetes, that was Prometheus. By its own definition, Prometheus is an open source monitoring system that has many advantages. Among the others, they have a dimensional data model, a very flexible query language, ProMQL. If you're familiar with that, you know that flexible is one thing. Easy to use is another one, but okay, we'll get there at some point. A time series database and also alerting. Another thing that we'll see how it changed in the OpenShift approach. Speaking of which, why we are talking about Prometheus? Because if you're running OpenShift, you might not know, but there is Prometheus there hidden. in disguise, but with many advantages, and you know, kind of adding where Prometheus has some sort of legs. What do I mean? And I promise, this looks like theory, but we will show them, we will show you and so on later with Manu. Just to give you sort of a comprehensive comparison between the two things. For example, Prometheus is something that you can install by using the official Prometheus Helm chart. In OpenShift container platform, you have it. You don't need to do anything. It's already in there. It's part of the platform. Second, Prometheus and also OpenShift container platform both have the core platform components out of the box, which is amazing. But then, if you start thinking at what do I need when I monitor? I need a monitoring system, check, and I need alerts. It's the first thing that I might need, otherwise it's pointless to just say, okay, I have monitoring in place. In Prometheus, you need to create your own alerts from scratch. That's another fantastic thing to do, and you use PromQL, so you might, it's taking that into account. In OpenShift, for example, you have predefined alerts. So of course, you can create more, but you got a set you can start with. Same for visualization. In Prometheus, you can leverage, for example, Prometheus UI. Not exactly the most friendly thing to use, nor the most powerful one. That's the real thing. Or you can use Grafana, which is pretty much the standard there. In OpenShift, you can leverage the OpenShift UI, the web console that you got there, that also leverage Grafana. You can create your dashboard or import your own in Prometheus, but if you're using OpenShift, you will already have out-of-the-box dashboards. So the point is you can focus on monitoring rather than building all around monitoring. And of course, both support all the security standards. It's just role-based access control for Prometheus. You got more on OpenShift container platform. That said, so just to set what we are talking about, let's kind of deep dive into the architecture of Prometheus.
Yeah, let's see the Prometheus architecture. So, well, about Prometheus, Manuela already gave us some introduction of what Prometheus is. So now this is the typical deployment of a Prometheus server using the Helm chart stack. So the core component of Prometheus is the server here, which is responsible for retrieve metrics from our applications or for Kubernetes or Linux or Windows, then store it in a time series database on disk, and then it allows to query these metrics using PromQL, which is a powerful language. Right here we have the targets. So the targets are basically our applications. So how do we expose our metrics? So we need exporters. Exporters are small applications that run along our applications, our components, and expose metrics. Normally are developed in Go. And these exporters gave metrics to Prometheus server, so Prometheus can pull the metrics from IP port / metrics, and then we configure in Prometheus our jobs to tell, hey, go to this IP and scrape the metrics. Sometimes we have short-lived jobs that just 1 minute or 2 runs only for 2 minutes. So instead of pull metrics, because we can't, if the scraping is more than 60 seconds or so, we can use the pass gateway. So we push the metrics to this pod or component, and then Prometheus scrapes from here. And then we have the marvelous service discovery, which gives us the power. So Prometheus can, out of the box, discover a lot of targets in Kubernetes or our applications using labels, annotations. So now we are only missing the alert manager, which is responsible for all the alerting part of Prometheus. Basically, you can create your alerts using PromQL so it's really powerful comparing with other applications. And then the alerts are sent to anything you have configured here, like email, Slack, Teams, or whatever you're using. And then how do we visualize our data that is stored here? We use normally Grafana. We've got the Prometheus interface, but I think it's more like for developers or just to see if we have metrics or to see the Prometheus configuration. But if we want to have dashboards and panels, we definitely use Grafana as our monitoring tool. So let's see how from Prometheus goes and evolves to OpenShift Container Platform Monitoring. So this is the diagram for OpenShift. As you can see, it's more complex. There are some parts that are the same. For example, we have here Prometheus server. Well, we have several. As you can see, there is that square are several squares. So it has high availability in OpenShift. We have the alert manager here as well. And we have targets here that Prometheus is scraping. Okay, so we have some components that are the same. What OpenShift does is create new components around Prometheus to make it more scalable so it can work faster and better, and to have a lot of jobs to scrape everything in OpenShift out of the box. So for example, we have the cluster monitoring operator, which is responsible for deploying the whole stack. It's an operator. So OpenShift uses a lot of operators in all of its applications. Then we have the telemetry client, which is a small application that sends Prometheus metrics to Red Hat cloud. So if you want support from Red Hat, it's easier for them to manage your metrics. Then we have here, in the platform part, we have a lot of targets out of the box, but a lot. All the core components of Kubernetes or OpenShift are there. So we have there the Kube state metrics, OpenShift state metrics, the node exporter. We have the OpenShift API server, Kubernetes API server. We have core DNS, etcd. So all of these things are out of the box, including alerts and dashboards. We will see later in a demo. And then we have other components like Thanos, because we need to query several Prometheus. So Prometheus out of the box needs something to query when you have several Prometheus. And then in the right part, we have like something that I will explain now in some minutes, because this part is a different Prometheus. Okay, so I will explain it now. So what OpenShift does is split the admin part from the user or developer or DevOps part. So if you are an admin, you are going to enter on your console and you are going to have all of this. So you get everything there. You have your console, you get your dashboards, you have a lot of alerts for Kube state metrics, for core DNS, and you get it. You don't have to do nothing. But what if you are an operations team or a DevOps team and you want to monitor your application? What do you do? Because for OpenShift admin, normally doesn't care much about final applications. They want to monitor cluster and workloads and some applications that they deploy. But users, what OpenShift does is create a specific project for users. So some teams can develop and deploy their own Prometheus and separate totally from the admin Prometheus. So you don't have to attack here. You are going to attack to your Prometheus. You can also use some queries to the other Prometheus using Thanos. But basically, you are going, as a user, you are going to access only here. So it's really secure. Sometimes you have here metrics that you don't want to expose to other users. And users can define what applications they are deploying, what metrics, in which port, and what they want to scrape. So they can create their own alerts using the alert manager, which this component, they use it both projects. And this is why we are going to explain now the steps. So the steps like stand, work, and run in the monitoring maturity path.
Because as you saw, it looks complicated, the architecture, or Prometheus, or OpenShift container platform. But the truth is that the takeaway is you got something you can monitor, you can metric for that, dashboards for that, alerts for that. But at the end of the day, it really depends on the strategy you build around that. So when we were thinking about how we can try to summarize what are the stages literally in a monitoring maturity path, we started thinking what we usually observe, what customers tell us. And we saw 3 different steps, let's say. The first one is, looks uncommon but is not, is the situation where something happens and sometimes everybody suddenly realizes that something wrong is happening and we need to respond to that. It might be an issue, it might be an escalation, it might be something going down. Think to the worst possible case scenario, but the truth is that happens. And there are still cases, trust me, where monitoring is not in place. So you can just react to that. Even if you got a monitoring system like the one we were seeing, if you don't really put some strategy into that, some thinking in, okay, what are the alerts I really care about? How should I manage them? Who should I alert? You will stay in the first step because you can just react. You have no idea. You didn't see that coming. If you start, for example, looking at least at your infrastructure and say, okay, so I got all of these nodes, all of these pods, all of these containers. What is happening in there? How do I know if they are performing well, if everything is fine, if they are healthy or not? And then you start digging deeper there. You start trying to understand what are the metrics at the container level, which is fine. I mean, it's relevant, especially if you're looking at your architecture. But when you look at your environments, there is more than just the infrastructure. There are all of your applications running there. And you want to have visibility over that, because that's where you really gain a full visibility on what you're doing on your environment, if everything is fine and how it's working, and how you can optimize it. And that's the first phase that we call the run phase. So on a path, you start really running because you kind of get the pace of monitoring and start monitoring more and more in a more efficient way. That's where the thing that you're monitoring actually are not just a reaction, but are something that you can turn into something useful for all the teams, for you, for the way you manage your infrastructure there. Just to give you an example, and then we will see it live. This is what would happen in a classical stand situation. You got a list of alerts. You remember when we saw the infrastructure, we said that there are alerts coming out of the box on OpenShift container platform. So basically, you didn't do anything. You just saw this list, and at some point, you realized that there are all of this critical severity. Oh my, maybe I should do something. That's exactly a thing. I should do something. But you realized only because you saw this. You could have avoided that eventually. It depends. But if you didn't put any brain on that, that's exactly what you will get. Then we said that you start walking on your path. For example, this is what you will get inside OpenShift when you are monitoring your container, literally the CPU usage in this case. You're starting to look for something different, something that relates to the metric of your containers. Interesting is a deeper look into something that it's auto-generated. So it's there, but at least you're looking at that. And now look at this. Look at the query over there. We are looking at something very, very specific, HA proxy in this case. We are starting monitoring application. We want to really understand what is happening inside our environment at all levels, not just infrastructure, but also application level. With this in mind, let us show you concretely how this works.
We've got a video, so I will just comment the video. So here, well, okay. So here is the typical web console, as you may know. So there are two parts, the administrator part and the developer. We are now going to center in the administrator part. So here we can see all of our workloads, pods, deployment. This is the typical, the OpenShift console you probably know. But let's go to the observability zone where we have alerting, metrics, dashboards, and targets. Let's start with targets. What do we have here? Oh, we have all the targets, all the applications that we are now monitoring, the kubelet, the node exporter. So we've got a lot of applications. This is all out of the box. I haven't put any application there. So this is the admin part. So hey, let's filter by the Elasticsearch that we have here. So we can see that we have a target, well, several targets because there are collectors as well. And here we can see the status, what is the service monitor, in what namespace, and the IP, port, and path that we are scraping. Now let's go to the alerting zone. So we have like alert silences and rules. In the rules, we have, this is all the rules that we get with OpenShift. So when we install it, we get all these rules. Let's filter by HTTP proxy. So we've got one for our router. So if we enter, we have one for, hey, your proxy is down. And this alerts when this expression happens. So this is a metric from the application. If it's equals 0, it will just send an alert, and it will appear here in a dashboard if it's down, but now it's not. We have also other rules for other applications, for example, for Elasticsearch there. Here is the firing part. So here we see what alerts are firing. So if we have a problem, these are only warning and info, but if we have a critical alert or we have a different problem. And then we have the silence. When we are doing a cluster upgrade or an application update, we want to create a silence, so we don't want to be alerted like for 3 hours. So we can create a silence here based on a label, name and value. And well, we just create it until 2 hours from now. We put a comment, so if any other admin can see it. And yeah, we create it. Okay, so let's go to another part in metrics. So in the metrics, we can query directly our Prometheus. So here we have a lot of metrics here and some recording rules that OpenShift gives to us. So there are a lot, as you can see. But we can also use our own metrics and expressions. So we can check for if our HTTP proxy is working or not. And we will get a dashboard with it. So hey, yeah, I've got like 2 containers here that are running in my namespace OpenShift ingress. Okay, so that's really cool because we can check metrics from here. And we can also change the threshold. So tell me, instead of 30 minutes, give me 1 hour or 1 week. So we can see metrics from different time. And then we've got the dashboards, which for me is the most important thing here, because we got all of these out of the box without doing anything. So we have a lot of dashboards here for the API, the etcd, the whole Kubernetes cluster, the login, node exporter, and we have filtered by request duration. We can see CPU, we can see memory, network, depending. Here we have as well verb. In the etcd one, we say, hey, your etcd is okay, you have 3 nodes, that's good. We can also see the streams we have or the database size, just in case that the database is starting to to increase without no explanation. And also we can see from Elasticsearch, which is our application, so we can see the status, our active shards. We can also inspect one of these dashboards to see what queries OpenShift is executing. So you have like, hey, give me, this is the metric, give me the max number of these metrics which are active, and the other one is active and primary. Okay, so you get two different lines. So now we have as well, this is the node exporter, so this is for our workload, so we can see the CPU, memory, network part of each of our workloads. And then we got the developer part, okay? So this is totally different, as we have the topology panel here. So this gives, in our project, and the user project, this gives us like at glance what's happening in our application. So we've got the strategy, how many nodes we have, if it's any alert, it will trigger there. So this is pretty cool for a user to see how is deployed their application. And in the observe part, it has not as many info as the admin one, but it's still pretty cool. So we see here our project, and we can see what's our CPU, of our Grafana, for example, or Prometheus. We can filter by pods or workloads, and we can choose one Grafana or whatever we have here. So we have a lot of data here, quotas as well, memory quotas, bandwidth. And then we have the metrics. So here we are going to query an application metric for the user, which there is in another namespace, in the default, it's an Nginx deploy. So this metric is in the Prometheus, in the user Prometheus space. So we got that, hey, our Nginx is up. So this is an application metric, and it's in the project default. So here is a simple query, but we could just do a harder query, or we can create our alerts. So this is an application alert, so this can be Nginx or can be our application. And it's pretty much the same. So hey, tell me if the Nginx is up or we are not receiving metric. The absent means that, hey, if we are not receiving the metric, just trigger the alert. We also have the events, so in our project, we can see what's happening with our pods, and if are changing from one state to another one. And well, that's it. So let's
go back.
Yeah.
It works. It kind of works.
Yeah.
Yeah. So, all in all, just to summarize, what are the perks there? You saw in the demo, the seamless integration with OpenShift is the biggest one, clearly. We got a pretty comprehensive, pretty big metrics collection. You saw tons of them, both for all the applications, but also for all the infra part. All the things that you remember in the architectural part came along with the Prometheus operator deployment. You got out-of-the-box alerts. You got security inside that. You got scalability, which is the most important thing there. It's a huge perk because we all know how much it costs to not be able to scale, and how much it costs also in terms of money, not just in terms of infrastructure. So that's pretty big. And in general, if we should summarize what is the business value, because at the end of the day, that's what we are talking about. All very cool about how we define our infrastructure, our architecture, and everything, but it's money at the end of the day. A better architecture can turn very quickly into a lots of money spent. So being able to optimize costs because we are not losing time in reacting to stuff that we are not monitoring, or because we got bad things that we are not looking at, or because we don't have an alert in place. Most simply, the most simple case can really turn into a lot of cost spent. I don't even need to mention, I guess, how much it would cost us to not secure what we are doing. So being able to leverage a platform that already is built for security is definitely a huge value there. It's reliable, has fantastic performances, which is another thing that you can really get along and get out of the box instead of spending days trying to do that. And it also improved the collaboration between teams. Because if you're all using the same platform, if we got something in place like we saw it, you do remember the architectural part where you got the admin here and the user here, something that can help us work together, being sure that what we do on one side is not going to affect the other and everything is working fine, is orchestrated perfectly. That things definitely will bring also a huge business value there. So it was just to give you a sort of first beginning commencement on what's the value of using and monitoring stuff with OpenShift container platform. What does that mean? How is that different from what we see in the rest of the market or what is available there? So thank you, everyone, and bring us your question. Thank you.
Yeah.
Wait, let me repeat the question because I don't think everybody heard. Why workload monitoring is not enabled out of the box? Go for it.
Yeah, it's not enabled out of the box when you install OpenShift, but it's there. So, yeah, you have to read the documentation. That's what I mean, yeah. So, yeah, it's there, but I don't know why OpenShift maybe in the console or in some place can help users to find it quickly. That could be a great idea because it is in the documents, you can read it and it's perfectly documented, but you don't see it here. So maybe in next versions we can find something. So that's a good idea for Red Hat to put it there, yeah. Yeah, the best idea is if you are scraping different applications from different teams and users, I will definitely deploy different instances, as they are not going to be very big, really big instances, as all the biggest instance always is the admin one, because it has a lot of time series and metrics. So probably your application is going to have metrics, but not like millions and millions. So it's better to have like a small Prometheus servers in your cluster than one or two really, really big. That does not scale, in my opinion, and that's what Red Hat is trying to do here. Good question. No, it's not. If you want to have custom dashboard panels, you must use Grafana. It's the best approach. You have the Grafana operator in the marketplace in the Red Hat, so you just install, you configure to attack Thanos, and then you get metrics from your Prometheus. You can download the dashboards from Grafana webpage if your application is the typical application. If it's your own application, you will have to create the dashboard. But no, now it's not. For instance, Red Hat tells you not to modify some components of the Prometheus. All the admin part, this is something that you must not touch much, as there are a lot of operators there, and it will modify something in the next version, and it will break something. So no, you can't create custom dashboards in this moment. Maybe in the following versions, it's easier. Because it's probably, Red Hat don't want you to like destroy the interface, because if you do something bad with a dashboard, maybe the interface starts like not behaving well, and yeah. So use Grafana is a really powerful tool. So or third-party solutions, which are a lot out there with out-of-the-box dashboards. I don't really know, as I don't work for Grafana, for Red Hat. But well, I don't think so. I mean, Grafana, they started to put Grafana there, and they moved to the operator. So it's not officially support as integrated in the stack, but it works. So, but I don't have the exactly answer for you. Thank you. Well,
Do you know if anyone is doing anything to make ProQL easier, like to use? You know, I sometimes do exploratory.
Yeah.
And after a while, I don't understand my own.
Yeah, ProQL sometimes.
I know that pain.
Yeah, it's a pain because it's when something is powerful, sometimes it's a pain. It's true. You have some webs like how it's called, Prometheus. Prometheus is a project, now it's open source, and it's a project that you put your query, and it explains you what's happening there, and it gives you the time of each query. So it just like splits your query, explains it to you what's happening there, and it gives you some information and time about the query. So it's a pretty cool.
An execution plan, but with some explanation
Yeah.
to the,
Yeah.
also the meaning of the code. Okay.
Yeah, so Prometheus, if you look there, I think it's now open source because it's from Chronosphere, I think.
Yes, it's from Chronosphere.
Yeah.
We had another in
Yeah, we had in
the back.
So it means we don't need Sysdig, right?
No.
That's a good one. That's a good one. Well, third-party solutions you always have for applications. You always get better dashboards, which are made by professionals. So here you must install Grafana for your custom workloads. You have to create your dashboard. You have to maintain it. So well, so that depends on how much you're going to invest.
Fantastic.
That's good.
We didn't pay them, I promise. And of course, for example, this is if you are just using OpenShift. With solution like ours, you might have different kind of, you might use OpenShift, but also, I don't know, AWS or other stuff, and you would have a consolidated view of everything all in one place. And
Yeah.
simplified ProQL queries, by the way.
Yes.
With the form, just to add.
The best approach is to have just one software solution for all your clusters, because you can have clusters from OpenShift, vanilla Kubernetes, you can have Rancher, so you try to have it all in one place. So, yeah.
My question is similar to the one from the same vein. Integration with third party, you guys mentioned, ask the question whether out of lots of third party, what are the best practices or patterns for integrating with third party like Datadog or?
Well, it really depends on your need. I mean, you can go from literally people building everything from scratch, because that's the need they have. So it's a very basic thing, doing stuff with Prometheus, remote write and everything. So a very, very basic thing that costs a lot of effort, but might be the solution, especially if you say, no, I want to only leverage all the open source stack, I want to build it on my own, and you will do that. When we just move to an enterprise level, you might say, no, I don't care, I just have OpenShift in my company. I only want to do that with OpenShift, and that's enough for me, because I just need that. Or you might have a bigger need, like ours. You might be a customer that need to monitor different environments in different areas. Or you might want to leverage powerful dashboards customizable by all of the users, not just the admin, like it is, for example, in OpenShift. So you might say, no, I want to have a solution that does it all, so I just have one access point, one single source of truth, and just use that for all of my environments, all of my applications. So it really, really depends on the strategy behind that. What I can tell you is that we got customers, so they can confirm. But what we can tell you is that consolidation is one of the things that people is really looking for when they come to us. They say, okay, that's fantastic, but I just don't have OpenShift. I even have VMs, for example. It might be there was life before Kubernetes. Or I might have things running on a Rancher that we were mentioning before, or pure Kubernetes, and I don't want to jump from one software to the other, or pay, even worse, pay more software and more solutions to just achieve what I'm trying to achieve, which is consolidation of all of my observability need. So that's exactly the kind of thing that is brought on the table by... Exactly, or go from scratch, which is painful, honestly.
Is it easy to access user data in OpenShift from an external Grafana with all the role-based access and everything?
Yeah.
Well, it's not easier. It's not easy, and it's something that I have Red Hat has to change. As you have to deploy your own Grafana in your namespace, and then you have to, using Airbag, attack the Thanos, because you can't attack directly the Prometheus. Now, the alert manager and Prometheus does not expose itself in OpenShift. It did in version, probably in version 4.3, 4.2, 4.1, but since 4.6 or 4.7, it is not exposed, so you can't access to the Prometheus console, you can't access to the alert manager console here. So yeah, it's hard to deploy a Grafana. You can do it, and if you are using the user-defined project, you should, as you always want custom dashboards. And you can there integrate it with using a bearer token with the Thanos. So you point to the Thanos, which it's exposing the port, I think it's 91 or so.
But the extended token you need to refresh? Or is it, can you static token use that in your external reference access Thanos?
You should use a static one. Yeah, if it's refreshing, you are going to lose connection as it can't connect.
Further questions?
So if we have an external Prometheus cluster, can we export these metrics out of OpenShift into the external Prometheus cluster?
Yeah, you can use remote write. So you can send your metrics wherever you want. So it's the same as if you want to send these metrics to your cloud provider, you have a managed Prometheus wherever, you can send it with remote write. And it's pretty cool as well, yeah. So there are a lot of solutions out there for users and admins here, yeah.
In terms of your company, customers overall monitoring strategy, what you get here out of the box, and obviously it provides everything you need. But really, it's not enough. Should you really look at like adding additional external probes or like a black box monitoring system, because your cluster goes down with it. So part of your strategy, it's not enough. You really should be looking at having like a primary or a basic monitoring solution as part of the overall strategy.
Well, yeah, that's exactly like that. Because I mean, the real thing is that, since you mentioned black box, when we were thinking about these phases, the real difference between the second and third is that the second is literally the black box. Something is happening there. You might want to get visibility, but still you're missing something there. And that's exactly really moving from work to run, being able to start monitoring applications is where things change. Because that's exactly where you really understand what is making you spend, understand where you're putting your effort, understand how you should improve stuff. So that's really where strategy comes into the game. Because all the others is kind of, I'm learning. I learned, now I see something, now I do something. That doing really, really needs strategy there. Otherwise, it's not really monitoring, it's just observing. Exactly, exactly. Always think to the personas that the target audience that is going to use those. Really, operation needs that. All the rest is relevant, but operations need that. All the rest is like, okay, thank you, but give me something I cannot own, literally. I can use to do better what I'm doing.
Thank you, everyone, for coming and for your question. It's been really cool.
It was fantastic.
Yeah.
Thank you.
Thank you.
Thank you, everyone.